Topics covered in Chapter Real Numbers. Welcome, everyone. Today, we begin our journey into the world of real numbers. This chapter is much more than just a review. It serves as the essential cornerstone for everything you will encounter in algebraic thinking and mathematical analysis. Our goal is to transition from your basic understanding of counting and fractions toward a much more sophisticated grasp of the continuous number line, which encompasses all rational and irrational values. To guide our study, we have three primary learning objectives. First, we will establish the foundational concepts by exploring the hierarchy of the number system, learning to clearly distinguish between natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Second, we will dive into the fundamental theorem of arithmetic. Here, we will perform an in-depth analysis of prime factorization, establishing how every composite number can be uniquely expressed as a product of primes. Finally, we will revisit irrational numbers. We will examine non-terminating, non-recurring decimals and study the rigorous logical proofs used to demonstrate the irrationality of specific numbers, such as the square root of 2 and the square root of 3. Mastering these concepts is vital, because as we will see in the next slide, these mathematical properties are the very tools used to power everything from global cybersecurity to modern engineering. Real-world applications of real numbers. Now that we have outlined the theoretical foundations and the core objectives of this chapter, you might ask, where do these mathematical concepts actually appear in our daily lives? The truth is, the concept of real numbers is indispensable in virtually every field of modern science and industry. First, let's look at cryptography and cybersecurity. The properties of prime numbers and the fundamental theorem of arithmetic, which we will explore in depth, form the very basis of RSA encryption. This is the essential technology that secures our global digital communications and protects your online banking transactions. In the realms of engineering and architecture, irrational numbers are just as vital. Constants such as pi and the golden ratio, known as phi, are critical for performing the precise calculations required in structural design, acoustics, and fluid dynamics. Furthermore, real numbers allow scientists to quantify physical phenomena with the extreme exactitude required for technological advancement. This includes everything from measuring the speed of light to tracking the decay of radioactive isotopes. Finally, in the world of finance, both rational and irrational numbers are essential tools. They are used every day in financial modeling to calculate compound interest, perform risk assessments, and power the complex algorithms used in global market trading.